Mm. Hello, Miss, and my name is Juan Carlos, and I'm going to explain my evidence one. At first, we start with the topic one. On the topic one, we saw the all the physics, like a resume of the physics. And the physics is the science that reaches the fundamental concept of modern energy and space, and the relationship among them. Physics are the most basic of the sciences, underlying all other disciplines of science, medicine, and energy. Physics are the problem solvers, often meeting new challenges and developing new theories. The most important physics on the physics, are Aristotle, Archimedes, Galileo Galilei, Isaac Newton, James Clerk Maxwell, and Albert Einstein. Physics are one of the oldest sciences in all the world. On nowadays, physics are divided in two big branches: the classic physics and the modern physics. Then we go to the topic 2, that is measurements and units. The measurement and unit systems are physical quantity, quantifiable or assignable property that is linked to a phenomena. One of the examples of physical quantity are mass, weight, length, time, etc. There's so many types of errors like systematic error, random error, absolute error, and relative error. And like an example of the units we have in the on these times are length, like the magnitude, length, mass, time, electric current, temperature, luminous intensity, amount of substance, and the units are meter, kilogram, second, ampere, Kelvin, candela, and mole. And the symbol is like these ones we saw here. Okay. Another example of SI derived units are surface, volume, speed or velocity, acceleration, force, work or energy, and power. The unit we use to these ones are square meter, cubic meter, meter per second, meter per square second. On the first we used Newton, joule, and watt, and that's the symbol. That's the symbol. Okay. And another units we used on the magnitude are length, mass, and this is the symbol. On length we used foot, inches, mile, and yard. Obviously in the United States, no, And we used the mass on slug. Another SI units that multiplies and submultiplies are the tera, the giga, the mega, the kilo, the centi, the milli, the micro, the nano, and the pico. And that's what are the like the space, that he used. And then we go to the topic 3. The topic 3 is scalar and vector quantities. The definition of vector and scalar quantity. The definition are some quantities that can be described by its number and unit. These kind of quantities are called scalar. That are that ones that you can, yeah, este, like scale, I don't. And the scalar quantities are which are measured by same units cannot of subtracted conventionally. That means algebra works of them. A vector quantity is a completely specified by magnitude and direction. It consists in a number of a direction and unit. Then we go to the topic 4 on the last, I think. Yeah. The topic 4 is the operation with vectors. The parallelogram method is only worked with two vectors. First, you have to draw with the Popper scale both vectors coming from the same right or point. Then we use triangles, draw parallel auxiliary lines, and are going to touch the tip of each vector. Yeah, this is all the steps we used to do the parallelogram method. Then those all the topic 4 was all talks about the methods we used to, well, yeah, we used to solve the problems. But in the topic 5, then go to topic 5, the description of movement in one dimension. And the analytical description of movement are distance, displacement, speed, velocity, instantaneous speed, and instantaneous velocity. The distance is the length of real path followed by an object in only has magnitude so scalar quantity. Displacement is the separation in a straight line between 2 points in the final and initial position. The speed is the travel distance per unit of time. It's a scalar quantity. The velocity is same like the speed, but the velocity is the displacement per unit of time. It's the same, you know. The instantaneous speed is a scalar quantity that represents the speed that instant which the object was given a point, and the instantaneous velocity is the vector quantity that represents the v velocity and any point c.